So this one I can see as an integral. First thing that I look for is this first part that says 5 over n. So that when I think about that, I think about taking an interval of length 5, so maybe from 0 to 5, and I'm breaking it up into n pieces, right? So that's the width of each interval. And then this I see to be the height of each interval. So I have 4 plus, and then this thing, 5j over n. So I think about this as 5 over n. This is 2 times 5 over n, and so on. So these are the values of x that we're plugging in, and we're going to plug in n of those until I get to 5, which is equal to n times 5 over n. And so I'm plugging those in. So really what I'm doing here is I'm taking a Riemann sum over this function here, which is 4 plus x, the square root of that, and I'm plugging in these things here. So it's the integral from 0 to 5 of square root of 4 plus x dx. So for the next one, I want to evaluate these integrals. And so what you can do is you can think about a function that has e to the x as its derivative. And so I know that e to the x has e to the x as its derivative. So e to the x would be the integral of that. And then for x to the first, I'm going to add 1 to the power, so I'll have x squared over 2, and then plus c. And this one involves a u substitution, which I don't think you have done yet, so I'm going to cross that one out. But if it were just the integral of sine x dx, we know that would be, dx, we know that would be negative cosine x plus c. This one also involves a u substitution, so I'm going to scribble out this 2 here and just make it integral from 0 to 4 of 1 over x squared plus 1 dx. And I know an antiderivative of that is tangent inverse. And I'm going to evaluate that from 0 to 4. So it'll be, the answer will be tangent inverse of 4 minus tangent inverse of 0. And so, so it's a good idea to maybe have written down somewhere all of the antiderivatives that you know, that you've gone over in your class.